Hi, my name is Daniel Bogdanoff, and today is March 15th, so we're going to be giving away our 15th scope as part of Scope Month. I also have with me today Mike Hoffman. He's a business development engineer here at Keysight, and he'll be doing the webcast on Friday, and he also has a blog post live today on the blog. So Mike, why don't you come on up? Whoa.
Hey, Daniel.
Hey, Mike. Thanks for being here.
Yeah, absolutely.
So you have a new blog on the blog post today?
I do.
You want to tell us about it?
Yeah, absolutely. So it's a blog all about signal modulation and frequency modulation. It's kind of a beginner's guide for anybody who's curious about how radio works or things like that. So give it a read.
All right, and then I think you have a demo for us. So the link for the blog is going to be below. And then, Mike, why don't you give us a quick demo on the scope?
Yeah, absolutely. Come on down.
Oh, gosh.
What we're looking at here is a signal with 50 hertz. I've put the oscilloscope into roll mode, which makes it a little easier for us to visualize the signal. Let's turn on a couple different modes of modulation, and we can see how it works. The signal we have here is 50 hertz at 5 volts. There are 3 types of modulation built into our waveform generator: amplitude, frequency, and frequency shift keying. If you'd like to learn more about each type, check out my blog post, or just simply press and hold on that type from within the menu. Let's start with amplitude modulation. We can see here the base frequency of our signal is still 50 hertz, but now we're amplitude modulating the signal at a frequency of 1 hertz, which is why we can see an envelope forming. If we choose frequency modulation next, what I'm doing now is modulating the frequency of the signal between 0 and 100 hertz in the sinusoidal fashion, but the amplitude is still staying the same. And finally, frequency shift keying. You can kind of imagine this as frequency modulation but with a square profile, and we are hopping between 2 predefined frequencies, the frequency of the signal and our hop frequency, which we can define here. This is popular in radar applications.
Thanks, Mike, for that tip. Like I said, the blog post will be linked below. Thanks for joining me, Mike.
You're very welcome. Anytime.
I'm going to leave that in. Let's go ahead and draw today's winner. Today's winner of the MSOX3104T is Erik Machoro. Congratulations, Erik. We'll be in contact with you. If that blog post sounded interesting to you, you may also like our playlist on making RF measurements using oscilloscopes. It'll be right here. Also, subscribe to our YouTube channel, like our Facebook page, and tell your friends about Scope Month using the share button below. Thanks for watching. I'll see you tomorrow.